Welcome to today's Cybersecurity Insiders webinar on the state of intrusion detection and prevention systems, Adapt or Die. My name is Holger Schulze. I'm the founder of Cybersecurity Insiders, the online community for cybersecurity professionals, and I'm your host today. Today's webinar is brought to you by Enea, and Enea is one of the world's leading specialists in software solutions for telecommunications and cybersecurity. The Cosmos division of Enea specializes in network traffic analysis that identifies and classifies data up to the application level. And this technology is embedded in cybersecurity solutions to improve threat detection and strengthen network protection. Intrusion detection and prevention systems, or IDS or IPS in short, have long provided a critical last line, right, of defense against sophisticated cybersecurity attacks that penetrate endpoint and perimeter defenses. They also offer an important frontline defense, right, in emerging networks that do not really have fixed perimeters, right, which often connect new kinds of devices that cannot support, conventional embedded endpoint security software. However, conventional IDS, IPS systems have some weaknesses, right, in usability, like generating high volumes of false positive alerts, and weaknesses in effectiveness, such as blind spots, blindness to many protocols and certain types of advanced threats, especially those using encryption to evade detection. Now, to better understand all of those concerns and how IDS and IPS is currently being used, and what the future might hold for this important technology, we conducted a comprehensive survey of cybersecurity professionals earlier this year, surveying folks in our 500,000 member information security community. Let's introduce our panelists. First, I'd like to welcome Laura Wilbur. Laura is an industry analyst in networking and cybersecurity with Terra Transition. And Laura will be moderating our discussion today. Welcome, Laura.
Thank you very much, Holger.
Next, I'd like to welcome Mark Durrett, and Mark is CMO at Stamus Networks. Hello, Mark.
Hello, thank you.
Excellent. And now I'd like to welcome Sébastien Sinot, and Sébastien is product manager at Enea Cosmos. Welcome, Sébastien.
Thanks, Holger, and welcome everyone.
Let's get started. And Laura, can I ask you to take it from here?
All right. First thing up, I thought maybe, Mark, you could just take one extra moment here and tell us a little bit more about yourself and about Stamus Networks. Very pertinent to our discussion today.
Sure. Thank you, Laura. Yeah, so I'm Mark Durrett. I lead the marketing efforts at Stamus Networks, which is a global provider of high-performance network-based threat detection and response systems. And I'm really excited to be discussing the results of this research today, because actually, most of our customers come to Stamus Networks because they're seeking to migrate from their current or legacy IDS, IPS solution to a modern alternative. And so a lot of the data that came out of this survey is very relevant to our customers for sure. Just a quick update on our company. As the headline reads here, we are a global company with a global customer base. Our roots are deep in open source network security, and early on in our company's history, we introduced the world's most popular open source implementation of Suricata, a turnkey solution we call Stealth. And we continue to invest in open source, but we do offer a commercial solution that we call Stamus Security Platform, which combines kind of the best capabilities of IDS, network security monitoring, and network detection and response, or NDR, to help our customers respond sooner to security incidents and detect them earlier. So that's a little bit about us. Thank you.
Great. Thanks so much, Mark. And now I will let Sébastien tell us a little bit more about himself and about Enea and Cosmos technology.
Absolutely. So I'm Sébastien Sinot. I'm product manager at Enea. I'm based in Paris. And we currently have different initiatives to improve the IDS systems thanks to our DPI products. First, we developed a plugin to integrate our DPI library, including traffic intelligence, into Suricata. So then Suricata can benefit, I would say, natively from our traffic intelligence data. And we'll see later on what that means and what it brings exactly to Suricata. And we had another initiative where we have developed a rule engine as part of our DPI SDK, which is capable to execute Suricata rules. So we can provide a full software development kit to our customer for them to build easily an efficient IDS. And I would say in both cases, the goal is similar. The goal is to enhance Suricata by providing advanced traffic visibility.
Fantastic. Thanks very much, Seb. And once again, also very thrilled that you can join us for the discussion today. Okay, first thing we're going to do is just do a quick check that we're all on the same page with how we're defining IDS, IPS, and why it matters. And then we'll present and discuss some of the key findings from this research. Now, we won't have time, of course, to cover all the findings, but a reminder for you all that as registrants, you will receive the full report after the webinar. After the discussion of these key findings, Seb's going to do a demo for us, showing how DPI technology can integrate with and enhance an IPS like Suricata. And of course, at the end, we'll have our Q&A. So now let's go on first with our definition, what we mean by IDS, IPS. Well, to put it simply, it's a technology used to detect and block threats by analyzing network traffic flows. And IDS detects threats in two ways. One, by matching signatures to known threats, or two, by detecting anomalies that could indicate unknown threats. Now, this detection can be offline for IDS, which can produce alerts, or inline for IPS, which can also block threats in real time. Now, the whole goal of this network-based approach is to catch threats that have evaded or simply just cannot be detected by endpoint and perimeter defenses. Now, these types of tools may tell you that everything is fine, but IDS can say, nope. Now, why is this so important? Well, we know from the unending stream of high-profile attacks like these, just for the first part of this year, that endpoint and perimeter defenses are not enough. We also know that perimeters are beginning to disappear anyway, and that unmanaged devices are becoming more common. So network-based defenses are really, really crucial today. And now, with that groundwork, let's jump right into some survey results. Now, the first one I thought we'd take a look at is research participants were asked a basic question with an interesting implication. We asked where they deployed IDS, IPS. 65% said on-premise, but an almost equal number, 64%, said on private and public clouds. Now, to me, this suggests that organizations, maybe for the first real sign I've seen for a while, are really becoming proactive about cloud security, and that they're looking perhaps to IDS, IPS to fill the gaps that we have in cloud visibility and security. But I'm really curious how this lines up with what our experts are seeing in the field. So Seb, that with you, that's in respect to security solution vendors, and you, Mark, with respect to your enterprise customers. So maybe, Seb, you could tell us a little bit what you're seeing in terms of this issue of IDS, IPS, and cloud deployments.
Yeah, sure. So first, I would say by definition, almost an IDS system must be deployed where the network traffic is, because it's supposed to analyze the network traffic. And to make it simple, today's network consists mainly on a simple router accessing cloud services. So the on-prem equipment is becoming more and more basic. So there's still need to monitor this traffic from the on-prem router. But obviously, the main asset of the company now are in the cloud, and the different cloud services may communicate together. And then this inter-cloud services communication escape completely the on-premise router. So this is why there's a strong need to secure the communication into the cloud and then to deploy IDS into the cloud where the company assets really resides. And I would say there's Another reason is more and more those services are not only accessed from the company offices, but the employees tend to access them from home or from hotel or from wherever. So the only way to get visibility on the traffic is to deploy IDS where those services, meaning in the cloud, because most of the traffic of an enterprise now don't even go through the enterprise at all. So that trend for moving IDS function or IPS function to the cloud is just following the normal trend of new network generation, I would say.
Okay, that's very interesting, Seb. Thank you. So that's our view from working with our vendors. And Mark, what about the organizations, enterprises themselves? What kind of discussions around cloud and demands, deployment patterns are you seeing with your customers?
Well, so first, I completely agree with Sebastian's comments that sort of by definition, the IDS needs to be where the network traffic is, and that is shifting. And as more and more enterprise workflows are migrating to the cloud and more teams are working remotely, we're definitely seeing an uptick in demand for cloud-based, generally speaking, network security monitoring, let's just say. In our case, the on-premise installations are still the majority. Our customers typically start their deployments on-premise as an initial project to sort of prove out the technology, and then they start a second project to deploy in the cloud. That said, we do have some that jump right into the cloud. I'll also just state something that's really interesting. We're starting to see some of our enterprise customers move some of their workflows back from the cloud back to on-premise, and we're not sure exactly why that is, but that's actually that's also happening occasionally. So, but to Sebastian's point, you need to monitor the network traffic where it is, and so in most enterprises today, that's a combination of on-premise and in the cloud.
Okay, very good, excellent. And to me, that makes sense that that there would be a large number of customers that would want to get to prove the technology on site first and make the cloud the second part of their deployment. Interesting. Well, this next question also touches a little bit on cloud. Respondents were asked what improvements in IPS, IDS protocol and application coverage would be most useful for them. And as you can see here, the number one response at 64% was business SaaS apps, followed by proprietary or legacy apps. And certainly on the proprietary side, we know most of those are being developed in the cloud now. And then the other three as well, communications, IoT, social media, they all point to this sort of consumerization, but also cloudification of enterprise IT, as well as, of course, the convergence that's going on now between IT and OT. So when I'm thinking about these, my question here was for Seb, and I was thinking about, again, the cloud topic. Seb, in your discussions with vendors, are you seeing a lot of demand for integrating the Cosmos software because of this desire for better coverage for cloud protocols and apps?
Oh yes, that's a very strong driver for our roadmap, because this is what the customer needs. During the last 2 years, just as an example, we almost double our support for such application, for the SaaS application. So we started obviously with the most common ones like Office 365, Google Drive, Teams, and all those. But now we see that enterprise tend to use more and more such application for very specific needs, like task management, text editors, or whatever. So there's a large variety of these applications that are used now, and not only global messaging system or global CRM, but for little application. So our goal is to double again, I would say, our coverage during the coming year, because there's a strong need for our customers to maintain visibility on this and get as much insight on the usage of those applications. So yeah, clearly that's a very strong driver from the market. Yeah.
Well, that's great, and that sounds like a roadmap update that'll make your customers very happy. And Mark, Do you hear the same things around the cloud protocol coverage, but also just in general? Are there some other challenges that you think are important when it comes to cloud usage with IDS or IPS?
Well, we sure do actually see the same situation that Sebastian was describing, and for us, it falls into both the sort of authorized use of these cloud services as well as the unauthorized use of these cloud services. So there are a lot of large organizations that suffer from sort of skunkworks programs and shadow IT. And in many cases, that stuff happens as SaaS applications, and the enterprise security teams don't know that their organization or groups within their organization are actually expanding their attack surface effectively by sort of implementing these shadow IT programs. So it's really important to know what's happening out there. One of the challenges with sort of deploying in the cloud is that the dynamic nature of the cloud means that services go up and down. It can go up and down at any time, and selecting the right architecture is often the biggest problem area for sort of cloud-based network security monitoring, and that organizations struggle to figure out, well, what exact traffic do they want to monitor. They have to make sure the packets they want to monitor get sent to the proper virtual probes, et cetera. And when they're running a hybrid model, they've sort of got to work out where do they want to put their central analytics console. Do they want that in the cloud also, or do they want to keep that on-prem? These are all super problems that are not difficult to solve, but they do add complexity to that situation.
Participants were asked if they are using their IDS IPS in standalone form. 39% said yes, but they're also using it in an integrated form with a lot of other types of solutions. And this is definitely an increase since the information I've seen in prior surveys. And this integrated use, looks like it's being led by XDR. And again, we've also seen an increase in demand, certainly from XDR, since the last survey that was done last year by Cybersecurity Insiders on NDR. So here, on the issue of integration, I'm wondering from you two, Seb and Mark, if you are seeing XDR as the most common use case, the most common integration for IDS, IPS, and then also what you think is driving the demand for XDR. So let's see, maybe Mark, once again, you can pick up first, and then we'll go to Seb.
Well, so XDR is sort of a loaded term today. It's early in the sort of XDR conversation, I think, and so there are competing sort of definitions of what XDR actually is. From our perspective, we see it. We sort of align ourselves with the Gartner view, which is that XDR is a unified security incident detection and response platform, correlates data from multiple security components, and so IDS can certainly feed into that system. We're seeing sort of the more advanced network security solutions, sort of full-blown network detection and response systems as a building block for XDR. But XDR needs to have telemetry from all the systems in the infrastructure for them to be effective.
Yes, and it also, it is also an interesting consideration also, I think, in evaluating XDR to see how closely, network detection and response, of which IDS is a natural part, and endpoint detection and response, which is also looking at, anomaly detection, of how well those are integrated. That's a lot of data and a lot of sources and technology to pull together. And Seb, I was wondering, are you see the same thing? What kind of use cases are people asking you about integrating with IDS, IPS, and XDR? And are there other use cases?
Yes, no, absolutely. And we can say XDR and NDR as an extension to IDS. IDS generate a lot of different alerts and different events, and you need, an analytics layer on top of that. to really see what's relevant and where the real threats are. So more and more IDS are not used as a standalone product for sure, but are part of a bigger solution that can be XDR or NDR. And I fully agree with Mark about the semantic discussion we can have about those concepts, but globally having a global solution. And yes, IDS are now integrating in such. For the IPS function, maybe it's less sure because I would say firewalling function must act in real time with minimum latency, and it must be able to take decision by its own. So IPS or firewall still remains a legitimate component as a standalone one because of this necessity to act quickly. But for IDS, yes, I fully agree now. It's the key component and the core component of a global solution, which could be XDR or NDR, yes.
Okay, great. Thank you very much. Next topic next question has a relation to that in terms of evolution and the way the IDS, IPS, and the role it's playing is evolving. This was a simple question of what type of functions do you use in IDS, IPS? And the interesting result here is that there's pretty much near parity between a reliance on IDS for threat blocking and for anomaly detection. And this is interesting because even as recently as just about a year ago in a 2021 survey, 74% of respondents found that anomaly detection in network traffic analysis, or NTA, was the primary strength of NTA over IDS, IPS. So is about the maturity level of anomaly detection with IPS, IDS. Is it improving and improving very quickly, or with these improvements being native to IDS, or is there still some external enhancers like machine learning components, based on anomaly detection that need to be paired with IDS, IPS?
Yeah, so this is an interesting question, and I find the data interesting because we typically don't see anomaly detection associated with the legacy IDS solutions. In fact, there's been sort of a distinct lack of innovation from the traditional commercial IDS players, and so we tend to see this functionality of anomaly detection associated with systems that are analyzing protocol transaction and flow records and doing deep packet inspection, much like a Enea solution is capable of doing. Now, with newer network detection and response systems, which sort of used to be called NTA, I think, before Gartner co-opted the NDR term. We're beginning to see big improvements in anomaly detection from both heuristic and machine learning techniques. And interestingly, the anomaly detection is still not incident detection. So anomaly detection is very interesting. Yeah. It's necessary, but it's not sufficient and many of these systems generate a lot of noise, because not every anomaly is, in fact, an incident. So in the more, you mentioned maturity. So in the more mature of these systems, however, they have mechanisms to help the security practitioner sift through these anomalies to find the ones that they should be paying attention to. That is, which of these anomalies represents a serious and imminent threat to the organization. So I think there's a wide spectrum of maturity levels in the solutions that are out there.
Very interesting. But let's look first here at encryption. Participants were asked how their IDS handled threat detection and encrypted traffic flows. And this is really important, of course, because more traffic is encrypted now, the majority, and more threat actors are getting good at using encryption to hide what they're up to. So as you can see, the respondents reported using 4 different techniques in about equal proportion, from analyzing remaining clear data, using a threat intelligence database, a specialized encrypted traffic classification tool, or using a proxy and just encrypting so you can see what's going on. So for this question, Seb, I thought we would talk to you because I know that encrypted traffic classification has been a focus of the Cosmos product roadmap for quite some time. Can you share a little bit about some of the opportunities and the challenges around encrypted traffic and for surviving what I recall one analyst called the coming encryption apocalypse?
Yeah, it's not really new. The apocalypse started almost 15 or 20 years ago. Yeah, I started actually working on DPI something like 20 years ago, where it was possible to do DPI by just doing pattern matching on the payload, and you can extract whatever you want on that. But obviously that's now, and for years already, become completely irrelevant. And there's new trends, new challenges like TLS 1.3, where even the server certificates are now encrypted, making the categorization of traffic even more difficult. So to do that, we have different approach, different techniques, but one of them is to complement a list of IP addresses, because that's still a good way to detect a service by knowing the public IP of most service. So embedding IP addresses into our DPI library is one way of doing that, but it's not sufficient. So we're complementing that with machine learning models to classify the traffic based on packet characteristics, because that still remains. So the size of the packet, the ratio between the upload and the download, the delays between packets, all this information still allow us to detect what service it is, because the behavior of a flow is very different if it's a video conferencing, if it's a chat, file transfer, file upload, peer-to-peer. So we can still classify the traffic based on that, but it now requires more machine learning models coupled with IP database, more than pattern matching on payload, which is not irrelevant. And yes, there's also new challenges that are coming over time, like the encrypted DNS, because now we can still rely a little bit on the DNS to classify the flow. But that probably in the coming years will disappear. So that's why we invest a lot on those machine learning models that allow us to keep visibility on encrypted traffic. So the trend is not new, and there's always new challenge coming in. And clearly, that's our focus to maintain the visibility for our customer, even in this condition. So it's an apocalypse, but if you take it the right way, there are solutions to fix that.
Well, that's fantastic, and that's good to hear that all of that research is taking place. That's going to be it's a very difficult challenge, but it sounds like there's some really innovative strategies being brought to it. Now, we're going to come back now to the anomaly detection and the issue of like alerts and knowing when an anomaly is innocuous or when it's a true threat. And that may be, it's hard to tell here. The number one was what you'd like to improve about your IDS, IPS, was improving detection of anomalous and evasive traffic. I wonder if all of that is just finding it, or then we get on to the next two, which are about alerts. If you find an anomaly, making it more meaningful. Here we have coming in number two at 45% was more definitive declarations, more meaningful alerts. And then 42%, of course, was automatic alert triage. So, Mark, we'll come back to you on this since we were discussing this earlier. And one, what would you tell a CISO about how they could evaluate whether or not a proposed solution is good at anomaly detection? And then in general, just your other thoughts about alerting quality and with a tool like that's just open source like Suricata.
Yeah, sure. So great question, Laura. I think there are two elements that a CISO should consider here. First, we need to look at the anomaly detection itself, evaluating sort of the breadth of anomalies that the system can detect. For example, can it identify unusual user behavior or just unusual protocol transactions, for example, or can it determine when a host is interacting with unusual domains? So there, I think most suppliers can explain sort of the types of anomaly detection that they offer, and it's important to sort of look and see whether that's the type of coverage that you need in your environment. And next, you need to evaluate the system's ability to automatically triage all of these anomalies to help the practitioner find those which present serious and imminent danger. As we mentioned before, that's because not all anomalies are actually bad. And not all bad anomalies present serious and imminent danger to the organization. So you really need to look closely at the solutions to see what sort of tools they have that enable the security practitioner to quickly assess the situation and get to the bottom of it.
Okay, great. That's very helpful. And Seb, I was just thinking about all the contextual data that comes with the Cosmos Advanced DPI technology and what that could do for alerting. But you're going to address that in our demo in just a moment. So we will wait and pause on that, let you address that during the demo. And for the moment being, though, I'm going to have Mark take our last question before we go into the demo. And for this one, we can see that we asked everybody, what's your confidence level in the future of open source, particularly like Suricata and Snort, and 50% are fully confident in the future, but a significant number, 40%, are uncertain. So for you, Mark, maybe you could say a few words before demo about what do you think is going on here? Why the uncertainty?
I think these results are actually a substantial endorsement of open source. That's partially because that I've seen the research and the response to the first question in the survey. Many organizations are likely using a system that's largely built on open source platforms, but they don't actually know it. They don't realize it. It's a commercial system. Yeah. I'd say we should probably look at those who responded with yes and don't know, combined together to think about, what's the actual number supporting the future of the open source world. But there's a tremendous amount of innovation taking place in the world of open source security, in particular in network security, and it's increasingly a popular option for many organizations. Even very, very large multinational organizations who can afford to invest in expensive commercial solutions have chosen to build their own systems based on open source software, such as Suricata and the Elk stack, for example.
Yes.
The appeal of open source is that it's fully customizable, right, and it's free. So it can be a great cost-effective start or way to get into a new solution, and in the right circumstances can provide the enterprise with significantly differentiated capabilities when managed appropriately with internal resources. I would say one more thing that we've heard from a number of these organizations, that the total cost of ownership associated with a sort of build your own system is almost always significantly higher than they anticipated. So when you're evaluating the true cost of a project, it's important to factor both the direct and the indirect costs associated with owning and maintaining and innovating on top of this homegrown solution.
Yep, I totally agree. I've always seen the same thing, and I think that's an interesting point and very valid that you bring up about the fact that how many people, not just in this survey, but in general, don't realize how many commercial solutions take this base of open source and build fabulous solutions on top of it. So great, thank you. And now we can get to our demo phase.
Okay, so prior to the demo, I would like to display just a couple of slides to explain the demo context, how it's set up, and what we're going to show. So first of all, an overview of what I'm going to demonstrate now is actually a Suricata, the output of a Suricata enriched by our traffic intelligence. So what we did is we integrated our deep packet inspection libraries into Suricata, what we call the Suricata enhancer. And then the Suricata is obviously providing what it usually provides, all the different alerts and flow information. But those information will be enriched by what we can provide in terms of traffic intelligence, like obviously the classification of the flows, the categorization, the families, the tags, and different set of metadata, security metadata we can add. So what's the added value of that actually? So we saw that one of the challenges with Suricata, with IDS in general, is that they generate a lot of false positive, and security analysts have difficulties to eliminate them, sort them, and do the triage, as Mark explained. So having this information about the classification allows journalists to focus only on the untrusted traffic. And we'll see that more concretely in the demo, and all the context we can provide facilitate investigation. But the DPI can also enrich the detection or blocking capabilities by detecting a lot of traffic that evades completely the IDS or IPS. There's a lot of different techniques that the attackers knows to avoid this detection. Like there's a lot of websites that evade traffic, or the domain fronting techniques to make a communication look like something legitimate, where it's actually not, anonymizer to hide yourself, or a lot of traffic like cryptocurrency, peer-to-peer, that you don't want to see on your network, and it's difficult to detect with traditional IPS or IDS. And that's also something that is a need from the market to enrich and strengthen the IDS. And more globally, providing a lot of insight, a lot of metadata for each of the application, even if the application are not standard, non-standard protocol. Providing all those metrics allow a better triage as well, but also allow to build machine learning models that are more efficient. Typically, machine learning models need to have as much data as possible to work properly. And enriching the output of Suricata with such data facilitates that work and make it more efficient. So how that works? Typically here on the right, there's an output from Suricata, a flow record, typically, where you have the classical information like the 5 tuples, the volume, number of bytes, etc. And what we're just adding into this existing record is some information from the traffic intelligence. So typically what we call the protocol path, which is the full encapsulation of protocol, and where Suricata will stop HTTP on a standard layer, we will classify a lot of what HTTP traffic it is. And here we see that it's something hosted at Amazon, and actually the application hosted at Amazon is Instagram. Then we have categories, obviously, of traffic families. So Instagram is a social media, mainly working on mobile and enforcing TLS encryption. So that's just one example, but obviously we support 4,000 different protocols, and with a strong focus on all evasive traffic, like any type of non-corporate VPN, HTTP injector, also a way to fake the packets to evade the protection, different type of tunneling like DNS to TCP. So we have a strong focus on that to enrich the IDS. And then the goal of that is mainly to provide the ability to create new types of rules. So it could be our blocking rules in IPS mode, so transforming Suricata into a next generation firewall where you're able to block applications such as torrent, for example, but any type of application, part of our 4,000 different applications we support can be blocked individually or per family, because we have categorization of traffic. So you can block all peer-to-peer traffic, all cryptocurrency, all gaming applications, for instance. So that's, I would say, a strong, very differentiating feature, being able to block categories of traffic based on the application detection. And it also can be used in alerting mode only, so purely IDS, in order to generate new categories of alerts that it's not possible to build with a standard IDS. So the same way, because we are detecting different type of tunnelings, all type of VPNs, we're able to generate alert when such traffic happen. Because especially for Suricata, as it's open source, the attackers know how to evade that. So having some secret source, being able to detect all this kind of, I would say, traffic that is not wanted or not professional in a way or another is quite important. So that's just to provide a context, but now I would like to illustrate that with a demo. So here it is. So to build the demo, what we did is we take all this enriched Suricata output into an Elasticsearch stack in order to build a few dashboards on that. So for those who are familiar with Suricata, you will recognize here the different type of events Suricata can generate. So the flow event, so you have one record per flow, alerts, which is probably the more important, the different protocols anomaly. And for different type of protocols. So Suricata supports roughly 20 protocols. You can have specific metadata for that, but only for 20 protocols, which is quite limited. Here you see the different event in times, and here are some details about the event. So all that is, I would say, natively from Suricata. What we are adding is the category of the flow here, the application itself, and the full protocol path, as we see in the previous slide. So we are enriching the Suricata output with this information. And what is for? So for instance, for TLS application, we saw previously that encryption is a big challenge for detection of malware or anomalies, because it's encrypted and Suricata will only see TLS traffic here. Suricata is quite blind on TLS traffic, so if I focus on the TLS traffic, you can see here, thanks to the deep packet inspection, that we're able to split this traffic and still identify which application it is. So obviously there's a large set of applications that working on top of SSL or TLS layer, and here we see a few examples. And even more than that, if I focus on that, if I'm looking at Netflix, we can see that okay, Netflix here is identified on top of HTTPS. But Netflix can also be sometimes hosted on Amazon. So in that case, obviously IP detection doesn't work because the IP address of the traffic is an IP from Amazon, but we're still able to detect that. And sometimes the the Netflix traffic come from a CDN. Here it's Akamai, and here again we're able to identify that. So why is it important to detect Netflix? Netflix, you probably don't care for IDS, but it's a way to discount false positive. I would say all the alerting you have from your Netflix traffic, all the record regarding your Netflix traffic, you don't care. It's a trusted application. So by being able to identify that, whatever way it is accessed on the network, directly on Netflix servers, through CDN, on top of Amazon, or whatever type of tuning you have, we're able to detect that and say, okay, this is safe, this is Netflix. So you're free to maybe block Netflix on your enterprise if you want, but if you want to leave it open, you don't really care about attacks on that. That's one angle of that. But on the other hand, we here classify the traffic per category. If I look at cryptocurrency, for instance, we see that we detect some cryptocurrency flows here. And Suricata, even with the latest sets of alerts from emerging threats, and what Suricata provides by default, it's not identified as an alert. So this type of traffic just evade the protection. And we're able to detect that. And if you have crypto mining in your enterprise, probably safe to close that. Same thing for all the different evasive traffic, the VPN, the tunnelings, all these kind of things. We see that we're able to detect many types of different evasive methods to go through firewalls and not being detected by IDS. I take the example of UltraSurf here. We see that there's absolutely no alert on that. So DPI is able to detect things that an IDS will not be able to see. And that's what an important topic for that. Also, our coverage for application is for industrial protocol, which is also a concern to protect what we call the OT traffic. That's also quite critical. All the different machines or all the industrial control systems must be monitored closely. And where we see that, okay, Suricata is able to detect DNP3 and extract metadata and of that, that's the only industrial protocol is able to detect, where there's many other ones that are able to be detected thanks to our DPI. So we cover more than 50 different industrial protocols here, and that's a great help for analysts as well. We saw that another pain point is the triage and how to discard the false positive and focus on what really matters. So thanks to the classification, you can quite easily focus on what has not been identified as a trusted application. So every time we have unknown TCP payload, unknown UDP payload, HTTP or DCRPC, SSH, where the application has not been identified, this is something that you need to really take care about. That's very critical. So being able to filter this traffic very easily provide you a priority for the analyst. Okay, it needs to focus on this alert first, and those alerts here are the most relevant because it's not identified. If it's an alert on Netflix, YouTube, you don't care. But if it's an alert on an identified payload, then it matters. And that's also what our customer like with our technology is having this capability, this context in order to focus on what really matters. Then I got a second dashboard here where actually I'm listing all the different Suricata alerts. So this is all the details about the Suricata alerts. That's the list of the alerts. And here we provide the classification. So we provide kind of context to the alert. If I take, I don't know, an example of one specific alert, so this one, which is usually critical because it means that stun protocol is used to cross your NAT, so you might have incoming connection to your network, which is something that you need to worry about. Thanks to the deep packet inspection, you can identify that, okay, this is WhatsApp. So it's a peer-to-peer connection for WhatsApp. It's not really important, so you can discard that easily. So even that Suricata raise that as a severity 1, so the high-level priority. If you know it's WhatsApp, it's probably somebody on the Wi-Fi using WhatsApp, and you don't really care. So this context really helps a lot the analyst and reduce the time the analyst needs to make to really see what is really relevant and where they need to act. So yeah, in short, this is actually what we're providing and the need for it.
Yes, yes. So there we go. Going to go to our Q&A. Thanks very much. That was a really interesting demo. Thank you. And Holger, I will let you moderate now the questions that have come in during the session.
Excellent. Thank you, Laura. All right, let's see. The first question, I'm not sure why we're even talking about IDS in 2022. Doesn't NDR, so network detection and response, do everything that IDS does and more? Who wants to take this one? Mark?
Yeah, sure. I can take that. So that's a great question. I think there's probably there are a few reasons for this. First, many large organizations, for many large organizations that we work with, the alert logs generated by their IDS is considered crucial evidence in their incident response. And unfortunately, the most popular NDR systems out there don't actually produce this crucial evidence. So organizations that are reliant on it are still deploying IDSs to generate those logs. So that's an interesting data point. And then secondly, some of the NDR systems are actually built on a foundation of IDS and network security monitoring data, flow logs, and transaction logs. And those have really advanced the state of the art by combining sort of the best of all those technologies, the IDS, the network security monitoring, and the network detection and response to create sort of a superpower system. And then thirdly, I think the innovation from companies like Enea, Cosmos, like you just heard from Sebastian, amazing technologies. And the work that companies like mine, Stamus Networks, are doing, they're bringing a new set of capabilities to sort of what was otherwise a pretty stagnant IDS space. So I guess that's how I would answer that.
Excellent. Thank you, Mark. Let's see. Seb, do you have any comments on that particular first question?
No, that's clear. That also for me, efficient NDR needs to rely on an IDS. There are some NDR that only relies on logs from firewall, for instance, but they are very inefficient, mainly due to encryption. If they just see IP addresses, it's not sufficient to build a proper detection. So for me, yes, to build an efficient NDR solution, you need to have as a core component an efficient IDS. And I fully agree with Mark on this.
Excellent. Thank you, Seb. Now, the next question, Your research seems to indicate respondents, looking for IDS to do more than it was designed to do. Is anyone actually doing any IDS innovation?
Maybe I'll jump in on that one again. I think I sort of already covered this, but frankly, the legacy IDS vendors are not doing much in the way of innovation. But as I did mention earlier, there are a number of smaller companies, including Enea, Cosmos, and Stamus Networks, that are doing a lot of innovation in terms of anomaly detection, data correlation, protocol detection, false positive reduction, event triage, and other areas, while still maintaining the sort of goodness that's part of an IDS, those IDS logs that I just mentioned, they're crucial in many organizations. Seb, do you have anything additional to add?
The coverage for better detection is obviously a topic of innovation where Stamus is leading on that. And there's also needs to filter out the data, because IDS can be quite verbose, and the performance remains an issue when it's come to large throughput. So the ability first to improve the performance is an important innovation topic with technologies like DPDKs and fast packet processing, but also a way to offload as much as possible the databases and the SIEMs that are on top of it by offloading by applications and discarding what's not relevant. So there's a lot of innovation also on that topic. Where obviously Enea is helping and is innovating also in that.
Yeah, absolutely, I agree.
Excellent. Thank you, Seb. Thank you, Mark. The next question: if my organization has budget for renewal of our IDS license, how should we decide if we should renew or look for something new? Mark?
Okay, so we deal with this quite a bit with our customers, and what we found in working with them is when they're trying to allocate budget for the project, whether it's a renewal or a new project, you really kind of need to answer three essential questions. First, how much longer do you have with your current IDS and IPS? That is, when is your system up for renewal? The second question is, at what point will this legacy IDS IPS sort of no longer be enough? If the threat landscape has sort of outrun the capabilities of your IDS IPS, then that's a really important consideration. And the third question is, are there any staffing issues impacting your operation of these legacy IDS IPSs? For example, are you not able to triage all the alerts, for example, that come in? I mean, we talk to a lot of companies that sort of take a store and ignore approach, right? They store those alerts, but they ignore them until there's been some breach that they've been notified about through some other mechanism. So I'd say you really need to look at those three essential questions.
Excellent. Thank you, Mark. Let's see. The next question: you mentioned XDR as possibly taking over or absorbing the functionality of IDS IPS. And I thought XDR was really more of an extended version of endpoint systems. Can you explain how this might happen?
I'm happy to take that one. Again, Sebastian, I hate to sort of jump in if you're okay.
You do, Mark.
Okay. Well, so some people do see it merely as an extension of their endpoint detection and response, or EDR systems, but others also see it as a natural extension of their security information and event management system, or SIEM, or their SOAR. But sort of the way we look at it, it's much more aligned with a concept that's called OpenXDR today, starting to gain some traction. But it's a unified security incident detection and response platform that sort of automatically collects and correlates data from multiple security components. Network is one element, endpoint is another element, server logs, etc. So I think the possibility of sort of XDR taking over or absorbing the functionality is maybe a little bit misguided in that sense, and that the XDR is sort of it's a higher level than sort of the network detection and response piece itself. It sort of takes on a more holistic view. So that's where I would answer that.
Yeah, absolutely. And yeah, I see also to the reason first, if you have a malware on a machine, the first thing the malware will do is probably deactivate your endpoint security system. So you cannot really rely on that if it's too late. Once again, the truth in the network, because you cannot hide yourself from the network. And the other challenge is due to the variety of devices on an enterprise, especially with connected device and all that. It's very difficult to add endpoint system in each and every device, in your printer, in your camera. It's just not possible. So once again, the network is probably, and it's clearly the best way to have complete visibility and control over your network. So XDR is not cannot rely only on endpoints. That is not. It's a good source of information, but it's not sufficient. It has to be complemented with IDS.
That makes perfect sense. Thank you, Mark. Thank you, Seb. The next question: can an open source DPI like Zeek improve Suricata in the same way as the DPI engine you demoed? Seb, I think that's fine.
Yeah, I think I can take this one. So Zeek is very powerful because its scripting engine is very efficient to analyze payload and make specific things. But such as Suricata is focusing on standard protocol, and it remains weak when it comes to identify what on top of encrypted layer, and also for industrial protocol is still quite weak. Can also say that Zeek would work in parallel with Suricata, so meaning double packet processing, double management, with like 2 systems to manage, etc. Where our approach to include DPI into Suricata makes that you have just one solution does everything that Suricata does, plus do the traffic intelligence. So it's quite an easy way to benefit from that. And yeah, Suricata and Zeek, okay, they can work together thanks to the community ID, but making inner join on 2 different sets of records, still complex operations, CPU consuming quite a lot of CPU. So I believe, yeah, our approach is a bit different and has a lot of advantages, putting the DPI directly into Suricata, comparing to put Zeek aside. There's a lot of advantages with our solution, I believe.
Perfect. Thank you, Sebastian. I think we have time for just one more question. And the question is, how does one determine if an anomaly-based threat is actually dangerous or not?
Oh, that's a very complex question that yeah, it takes a long time to answer, but we can maybe provide a few tips here. So once again, the application in identification is a great help because you can discard all the alerts for the trusted application, which is one way to discard and focus on what really matters. Once again, when you get alerts on unidentified protocol, unidentified payload, that's obviously what is the most interesting and the most dangerous. So the DPI allows the triage and focusing on what's more important, and allow to discard a lot of alerts, a lot of logs from trusted applications that you don't care. So that's for me one important approach. And then also you have I would say machine learning based approach, where what matters is what's new on your network, what you have never seen on your network, and that's also important things you need to focus on. And here the granularity of the identification help for that. If you have 90% of your traffic which is SSL TLS, if you get a variation on one of the application on top of that, it will be flooded into all the information, all the traffic. But if we're able to split correctly this traffic, then a variation will be much more easily highlighted. So obviously it's a complex stuff, and Mark can probably complement on that, but we can provide part actually of the solution for this.
I think those are great points. Honestly, I don't have too much to add to that, Sebastian. Those mechanisms that you mentioned are, I believe, super effective. And when they're combined with one of the things that we do in our system is support this notion of tagging and classification, and that allows an experienced analyst to create a set of guidance to the system, so that when protocols that you don't care about, or IP addresses that are alert types that are known to be okay or not anomalous, or activity that we know could be anomalous but is not dangerous, can be completely filtered out of that event stream, and you're only presented with the newest, sort of first time seen information, and then that package together can really aid in filtering through what matters and what doesn't.
Excellent. Perfect closing statement. Thank you, Mark. Thank you, Sebastian. And yeah, Laura, it looks like we have a couple of links up on the screen, couple of pieces of content. And anything you want to call out here that would recommend our audience to take a closer look at?
I think that, well, number one, be sure everybody, since we could only cover a few of the survey questions, to download the report and get the full survey results. And then also, if you're interested too at everything that Stamus is doing, explore their products and Enea Cosmos. And then in terms of the demo, what you were seeing from Seb, the Suricata solution brief that looks at the integration of the two technologies we saw today is really interesting and goes into a lot of the different use cases and the way those work together at a tech level. And so thank you to the panelists, and thank you, Holger, for the research and putting this together.
Excellent. Thank you, Laura. Thank you, Laura, and Mark and Sebastian. Thank you for sharing your insights on intrusion detection and prevention systems. And this was a very educational session, and we got very positive feedback from our audience. Thank you again.
Thank you, Holger, and thank you for all that.
Thank you
for your time.
Excellent.
Thank you. Thank you to the audience for hanging in there with us.
As we're closing this webinar, thank you all again for joining us. I hope you enjoyed today's presentation. And I hope we will see all of you again at one of our future webinars. Thanks, everyone, and have a great day.